Forces are everywhere. They keep electrons around the nuclei, they keep you on your chair, and they quite literally hold the universe together. For us to understand how the universe works, we must understand the forces that govern our world. But I have a question for you. Why aren't atoms flying apart as we speak? Think about it. Positively charged protons are forced together in a space hundreds of billions of times smaller than the width of a human hair. Now, if like charges repel each other, which they do, then the nuclei of atoms would be forced apart. So what's going on here? There must be a stronger force than the repulsive force of electromagnetism that is keeping our nuclei in such a stable state. And there is. This is the strong nuclear force. All forces are caused by exchanging force carriers called bosons. They are packets of energy that are analogous to two basketball players. Throwing the basketball to each other will carry momentum to each of the two players backwards. This momentum forces them apart and causes repulsion. Attractive forces use the same principle, only the basketball is sort of like negative momentum, which brings the basketball players closer together. This isn't very accurate to what actually happens, but for the sake of this video, visualizing it like this will do. Now that you know this, let's take a close look at the structure of an atom. The nucleus is made of protons and neutrons, but that's not all there is to it. These are quarks, a fundamental particle that, as far as we know, can't be broken into smaller parts. There are 6, but all the matter we see is composed of only 2, up and down quarks. A proton is made up of 2 up quarks and 1 down quark. Remember those bosons I was talking about earlier? Well, the one that is responsible for the strong nuclear force is called the gluon. The quarks exchange gluons constantly and quickly, which creates the attractive force. The gluons create a force like a rubber band, only getting stronger the further away the quarks are. This interaction holds the quarks together to make a proton. The same force holds the neutron together, only with 2 down quarks and 1 up quark. However, the force only works at an extremely short distance, approximately 10 to the power of negative 15 meters. That's a little over the diameter of a proton, which is why it works to hold one together. In the nucleus, there is still a little bit of leftover force that is just strong enough to attract the protons with other protons and neutrons. How strong? Altogether, the strong force is approximately 137 times stronger than the repulsive force of electromagnetism. Surprising as it may seem, it's also 6 duodecillion times stronger than the force of gravity holding planets in their own orbits, evidently strong enough to hold everything together on an atomic scale. So what does this go to show? Sure, that's how things work at the most basic level, but why should I care? Here's why. The more you know about the universe, the more of an appreciation you'll have for the smallest things in the world. We live in a world that is so beautiful, so vast, so complex, that we sometimes miss some of the smallest things that we take for granted. Sometimes it's better to just reflect on them and remember what's keeping us together in the first place. The bottom line is, there's more to it than meets the eye.